Assalamualaikum and very good afternoon. Environmental technologies. In the last chapter, one of the important chapter for your final exam. Wastewater treatment consists of applying non-knowledge, non-technology to improve or upgrade the quality of wastewater. Large volume of wastewater are involved. The treatment process are carried out on continuously flowing wastewater, continuous flow or open system, rather than a batch of series of periodic treatment process in which treatment is carried out on parcel or batches of wastewater. The wastewater treatment can also be organized or categorized by the nature of the treatment process, operation being used physical, chemical, or biological. For physical treatment method, this method include process where no gross chemical or biological changes are carried out, and strictly physical phenomena are used to improve or treat the wastewater. The common example is cost screening to remove larger entrant object and sedimentation or clarification. In the process of sedimentation, physical phenomena relating to the settling of solid by gravity are allowed to operate. Usually, this consists of simply holding wastewater for a very short period of time in a tank under constant condition, allowing the heavier solid to settle and removing the clarified effluent. Chemical treatment method as usual. Chlorine, a strong oxidizing chemical, is used to kill bacteria and to slow down the rate of decomposition of wastewater. Another strong oxidizing agent that has also been used as an oxidizing precipitant is ozone. Coagulation consists of the addition of a chemical that through a chemical reaction form an insoluble end product that serves to remove substances from the wastewater. Polyvalent metals are commonly used as coagulating chemical in wastewater treatment, and typical coagulant would include the lime, which is also used to neutralization or adjusting the pH. Iron containing compounds such as ferric chloride and ferric sulfate and aluminum sulfate or alu. For biological treatment, this method microorganisms, mostly bacteria, in the biochemical decomposition of wastewater to stable end product. More microorganisms or starch form and portion of the waste is converted to carbon dioxide, water, and other end products, including methane. Generally, biological treatment method can be divided into aerobic and anaerobic method. While the devices used in wastewater treatment are numerous and will probably combine physical, chemical, and biological methods, they may all be generally grouped under six methods: primary treatment, secondary treatment, disinfection, sludge treatment, and tertiary treatment. For preliminary treatment, at most blunt, preliminary treatment is used to protect pumping equipment and facilitate subsequent treatment processes. Preliminary devices are designed to remove cut up the larger suspended and floating solid, to remove the heavy inorganic solid, and to remove excessive amount of oil or greases. Common preliminary treatment is screen Normally use rag, bar, or fine comminuting devices such as grinder, cutter, and shredder, grit chamber, and pre-aeration tank. Primary treatment. In this treatment, most of the settleable solids are separated or removed from the wastewater by the physical process of sedimentation. The purpose of primary treatment is to reduce the velocity of the wastewater sufficiently to permit solid to settle and floatable material to surface. Primary devices may consist of settling tank, clarifiers, or sedimentation tank. Settling tank can be divided into four general groups: septic tank, two-story tank, in-office method or type of the two-story tank, and other proprietary or patented unit. Blend sedimentation tank with mechanical slash removal and upward flow clarifier with mechanical slash removal. Secondary treatment. Secondary treatment depends primarily upon the big organism that biochemically decompose the organic solid to inorganic or stable organic solid. The device used in secondary treatment may be divided into four groups: trickling filter with secondary settling tank. This is the trickling filter. Activated slush and modification with final settling tank. Intermittent sand filters and stabilization pond. Disinfection. Application of chlorine to the wastewater for the flowing purpose. Disinfection or destruction of pathogenic organism. Prevention of wastewater decomposition that lead to for avoid to odor control and protection of plant structure in plant operation, such as sedimentation, trickling filter, and activated sludge bulking. In view of the toxicity of chlorine and chlorinated compound for fish and other living organisms, ozonation may become commonly used in the future. Flush treatment. The solid removed from wastewater in both primary secondary treatment unit together with the water removed with them constitute wastewater sludge. Two objective. The removal part of or all of the water in the sludge to reduce its volume. The decomposition of the organic solid to mineral solid or to relatively stable organic solid, accomplished by a combination of two or more of the following methods: thickening, digestion with or without heat, drying on a set bed, open or covered, conditioning with chemicals, elutriation, vacuum filtration, heat drying, incineration, wet oxidation, and centrifuging. The last is tertiary or advanced wastewater treatment. This step removes stubborn contaminant that secondary treatment was not able to clean up. Wastewater effluent become even cleaner in this treatment process through the use of stronger and more advanced treatment system. Tertiary treatment technologies can be the extension of conventional secondary biological treatment to further stabilize oxygen-demanding substances in the wastewater or to remove nitrogen and phosphorus. Tertiary treatment may also involve physical chemical separation techniques such as carbon adsorption, flocculation, precipitation, membrane for advanced filtration, ion exchange, dechlorination, and reverse osmosis. Softening process in recharging process. Okay. Primary and secondary wastewater treatment has proved to be insufficient to protect and receiving water or to provide usable water for industrial or domestic recycle. Therefore, advanced wastewater treatment will be defined as any process designed to produce an effluent of higher quality than normally achieved by secondary treatment process. This is the definition. What is constituted as advanced wastewater treatment? Advanced wastewater treatment may be broken into three major categories: tertiary treatment, physical, chemical treatment, combined physical treatment. Goal of advanced wastewater treatment. Advanced wastewater treatment is used for the following: additional organic and suspended solid removal, removal of nitrogenous oxygen demand, nutrient removal, removal of toxic material. But why then is additional organic or suspended solid removal by advanced treatment necessary? For the point number one, advanced wastewater treatment plant effluent may be recycled directly or indirectly to increase the available domestic water supply or reuse the water. Advanced wastewater treatment effluent may be used to industrial process or cooling water supplies. This is process integration. Some receiving water are not capable of withstanding the pollution load from the discharge of the secondary effluent. Secondary treatment does not remove as much of the organic pollutant in water as may be assumed, so it acts as a emergency plan or unit. Aerobic treatment system. An aerobic treatment wastewater treatment system is specifically designed and engineered for the treatment of wastewater. The treatment is achieved by microbes that oxidize and decompose the organic compound in the presence of oxygen. In this case, aerobic treatment system here is the advanced wastewater treatment system. Although by definition, by design, this is considered a secondary treatment. It can be tertiary treatment based on this definition. The second point, if you need the effluent to be higher quality than normally achieved by secondary treatment also, then it's considered as a advanced wastewater treatment. The advantage of aerobic treatment system is the complete treatment of the wastewater used as the final polishing step before the discharge of wastewater. The disadvantage is high land requirement, more expensive to operate than a septic tank, high energy required for the operation of the treatment plant, include mechanical part that can break down. So this is an example of aerobic treatment system under tertiary treatment or advanced wastewater treatment. So you have four examples here. First one is fixed activated sludge treatment. This system is an aerobic wastewater treatment system that utilizes an aerobic fixed film process that is a combination of the conventional trickling filter and activated sludge processes. The system is designed to be installed within a two-compartment tank or into a two-tank system where the first compartment or tank provides a primary settling zone for incoming sewage and the second houses the actual treatment unit. The technology contains submerged media specific to the application which provides surface area for microbial growth. But the second point is the description of the system. An aeration and circulation are provided by a blower that pump air into a draft tube that extends down the center of the tank. fixed activated sludge system. Second one is fixed film trickling filter. This is a treatment system that follow a primary septic tank in which the solids are settled and partially digested. The septic tank effluent flow to the trickling filter unit where microorganisms present in the wastewater attach to filter media and use the nutrient and organic materials provided by the constant supply of fresh wastewater to form new cell mass. The open space within the media allow air to freely pass through, providing oxygen to support the microorganism. The system may be equipped with a recycling line for pumping or recycle solid from trickling filter below the media back to the primary tank. Final effluent may be recycled back to the head of the treatment to provide additional treatment, denitrification, or out to final discharge. Is the concept is similar to the trickling filter. Yeah, it's similar concept. Right? The third one is sequencing batch reactor, SBR. This is a sequential process in which all major process steps occur in the same tank in sequential order. So you have only one tank, a batch reactor, but inside the tank you have several sequence or cycle. For example, the first sequence is substrate input or denitrification, which take up which is 33% of the cycle. The second was carbon removal and denitrification, clarification, treated water removal, and excess sludge. So you have a six sequence altogether, which have varied volume, and the sequence, this is a duration for each of the sequence. So in this process, aeration and clarification can all be achieved in a single reactor. So to describe this process, you need to know each of the sequence what it do, what is clarification, carbon removal, treated water removal, and excess sludge removal. The last one is submerged attached growth bioreactor, SAGB, or aerobic biological feed bed technology. This is a biological reactor in which the media is submerged in the process flow. Many SAGB configurations have been conceived and utilized for the oxidation of soluble organic matter and for biological nitrogen removal. The main component of SAGB are the media or biofilm growth and the under-drain system for even distribution of air and water. The media in SAGB has a high specific surface area that allow for the high biomass concentration. leading to a short hydraulic rotation time and thus a significantly reduced vector volume. Shear fit to an aeration column. From aeration column, it will pass to the SAGB. Inside the vector is granular activated carbon. This is a Vidas bed column. Yeah, I think you get the idea. So the effluent water will come out on top of it, and there's a recirculation line as well in case the effluent is not meeting the standard. Zero liquid discharge system. This is a cleaner production strategy. A zero liquid discharge system have become a necessity for highly polluting chemical industry. Generating concentrated effluent as a biological system are often failed to hit the statutory discharge limit. So in this zero liquid discharge system, the liquid is reused. See here, from the physical pre-treatment, magical treatment, so goes to the membrane filtration. From the membrane filtration, the clean water will recycle back to the building, but the concentrated pollutant, thing, can say it pollutant, will go to evapor concentration. It will evaporate the highly concentrated water here and recycle the water, and while the remain of the evaporation normally in soft or solid will be collected as a sludge. Yeah. So no water escape from the system, ideally. Step means ZLD, zero liquid discharge. Primary treatment is physical chemical treatment to remove grit. This is similar to the primary treatment to remove solid, suspended solid. Evaporation isolate the low volatile compound and dissolve solid through the series of evaporators. Secondary treatment is biological treatment, condensate from MEE and TFT. MEE, multi-effect evaporator. ATFD is aggregated thin film dryer, and low TDS effluent will be combinedly treated through biological system by filtration tank. The last tertiary treatment is reverse osmosis, which is a membrane treatment will be processed through reverse osmosis to isolate wastewater for use in the highly concentrated water to the beginning of pre-treatment system. Back to here, water evaporation. Process description, fluent primarily segregated into two streams, namely high total dissolved solid, have HTDS, high total dissolved solid of 15,000, more than 15,000 milligram per liter, and low total dissolved solid LTDS, less than 15,000 milligram per liter. The HTDS and LTDS means water is collected into separate collection tank is subjected to primary treatment in individual stream. The primary treated HTDS is taken to MEE, multi-effect evaporator. So steam stripper and the condensate from the MEE is subjected to secondary treatment, followed by tertiary treatment along with the treated wastewater from LTDS. Unit operation of primary treatment, oil and grease trap, equalization tank. Equalization tank is provided for the attenuation of variation in waste flow rate and characteristic. Mixing is provided in the tank for homogenization. Avoiding anaerobic condition and also keeping solid in a suspension via bubbling air through a grid connected to air blower. The flash mixing tank is needed for mixing of chemical in the wastewater. Chemical is like alum, caustic lye, and polyelectrolyte added for coagulation. Flotation tank flocculator device for flow machine is needed for enhancing the coagulation of particles for the formation of bigger flock. Clarifier tube tank, the flock from in the flotation tank gets settled in this tank in the form of sludge, while the clear water overflow from the top of the tank. Multi-effect evaporator. The chief factor influencing the economy of an evaporator. This is still inside the ZLD. So for multi-effect evaporator, the chief factor influencing the economy of an evaporator system is the number of effect. So by increasing the number of effect increase the economy of an evaporator system. The first effect of a multiple effect evaporator is the effect to which the raw steam is fed. Vapor obtained from first effect act as a heating medium for another effect. So you can see here feed contain sugar. So the saturated steam will flow inside the evaporator to heat the feed. Once it hit the feed, it will let out or outlet here, while the heated feed will go inside the second evaporator, and mm, the steam from the first evaporator will go to the second evaporator. So you can see only one flow of saturated steam needed. This is from boiler. The other evaporator will use the generated steam. Yeah. So this slide prepared based on Mackenzie L. Davis 2020 wastewater and wastewater engineering design physical and practice second edition by Wiley. Second one is Angie Reddy, Maredi, environmental impact assessment theory and practice Xavier. For the advanced wastewater treatment, it is based on Angie Reddy, Maredi book. So thank you.